You're so rational, and you are not. Rational Numbers by Rampage Math. Today we're going to learn about rational numbers. So let's have definitions, then we will convert rational numbers, and then we're going to graph it in a number line. When you were a child, you started counting with 1, 2, 3, 4 because it goes so natural. You have your numbers in your fingers. We call them the natural numbers. You don't start with 0, you start with 1. So we call this the natural or the counting numbers. They are the same thing. Take your natural numbers, 1, 2, 3, 4, 5. Then there's a UFO over here. Or like could say there's a 0. Put a 0 there. So include 0 with your counting numbers. Okay, we now call this your whole numbers. Whole numbers include 0, while counting numbers does not include 0. Whole, that O represents 0. Take your whole numbers again, 0, 1, 2, 3, 4, 5, and graph it in your number line. That's your number line. And then don't forget, you have a counterpart. On the other side of the world, you'll have your negative whole numbers. So this whole subset will have a specific name. It includes the whole numbers and their opposites, including 0. We call this now integers. Notice that so far, none of these subsets have included the decimal and the fractions. Don't worry, we have a space for you. Let's organize. Natural numbers, whole numbers, integers, and then we have those fractions, decimals, and percents. All of this, not just this, all of these are called rational numbers. A rational number is a number that could be written as a ratio. Ratio means like a fraction of two integers except 0 in the denominator. You could write it in the form A over B in such a way that A and B are integers, but you're not allowed to put 0 as a denominator. Look at this. These are all rational numbers. Can I make it as an integer A over B? Yes, I can. 5 becomes 5 over 1. Changes to improper, that's going to be negative 7 over 5. 0.25 or 25 hundredths. So you're saying it as a fraction now. 25 hundredths or 1/4 is again an integer over an integer. And 0.6, never ending or non-terminating, is actually written as 2/3. See, they are all now written as an integer over an integer. Therefore, it is a rational number. So let's generalize. Rational numbers could be represented in different ways. I could write it as a fraction, a decimal, and a percent. That's why you could equate one from the other. More examples of rational numbers. This one is a decimal but ended at 4. This is a decimal that ended at 6. These never end. This one, if you divide in your calculator 6 divided by 7, you will get a non-terminating decimal, but it will see some patterns. If you divide 2 by 3 in your calculator, you would see the never-ending 6, but the pattern of 6 is always there. Let's generalize. We can say now that rational numbers can be decimals that come to an end. Like in this case, they come to an end, or rational numbers can be decimals that do not end. They don't end and have a pattern. A pattern of numbers, a pattern of 6. How to decide now if the decimal equivalent is rational? When you change numbers into decimals by dividing by the numerator by the denominator, the resulting decimal number will either terminate. It will terminate. 1 divided by 8 is 0.125. It ended. Good. It's still a rational number. But if I divide 2 by 3, it never ends. But there is a pattern, therefore it is still a rational number. Now, let's summarize everything. So natural numbers, including 0, makes it a whole number. Get the opposite, it's an integer. But if you would still write them as an integer over an integer, all of these are called rational numbers. We convert rational numbers from one form to the other. Fraction to a decimal, simple. Divide the numerator by the denominator. Just D it, just divide it. But take note, the 5 goes inside, the 11 is outside. Just divide, put a decimal point, put it up, and then put an extra 0 so you could divide it. 50 divided by 11 is 4. 4 times 11 is 44. Subtract, you'll get a 6. Bring down another 0. 60 divided by 11 is a 5. 5 times 11 is 55. Subtract, you get a 5. Bring down another 0. 50. And you would notice that it goes back to 4. Yeah. And then it goes back to 5. So what do you think? Do I keep on adding zeros? It will be a continuous pattern of 4, 5, 4, 5, 4, 5. See? So this is non-terminating. It never ends. A rational number because there is a pattern. A repeating pattern of 4, 5, 4, 5, 4, 5. So 5 11s, which is non-terminating with a pattern, is still a rational number. Put a bar, of course, because that's the number pattern that doesn't end. Mixed fraction to a decimal. Don't be scared about this mixed number because it has a whole number. Simply set aside the whole number, convert the fraction, and then put them together. So cover these two, work on 3/5. All right? So 3 divided by 5, I put a decimal point. I get a 6 times 5, that's a 30. Subtract, I get 0. So terminating could still be called a rational number. Okay, but don't forget, at the end, put them together, that's negative 2.6 or 2 6/10. Decimal to fraction, let's do the opposite. The rule is simple. If you can read it, then you can write it, then simplify it. Remember the tune. Read as 125 thousandths. Remember, tens, hundreds, thousands. Always mention the last place value. So, as I read it, I can already write it as 125 thousandths. The bottom will be thousands. So, I write 125 on top, 1,000 below. Guess what? It's already a fraction. All I need to do is simplify it. Divide by 125, divide by 125, I get 1/8. So 1/8 is the equivalent fraction of 125 thousandths. Practice. Convert this. Divide. Is the division right? Check it out. Which number repeats itself? Is it 1 or 6? It's just 6. Therefore, the bar stays at 6. Convert to a decimal. Does it end or not? This is kind of tricky because if you have 11 over 17, you get your calculator, you will get a number that ends at 4. It terminated. It ended at 4. Check again. Because if you use another calculator, a longer digit calculator or your computer, you would get a value that looks like this. All right? So 0.64705. And you would see that the pattern ends at 7 here. At 117. Then it begins at 64 again. And then it ends there at 117. Begins at 64 again. So the pattern of repeating numbers is quite long. And it doesn't fit here. So it has a pattern. You could still say it is rational. Don't judge immediately by saying it's irrational because you don't see the pattern. The calculator just doesn't have the space to contain everything. So we will now graph rational numbers. So they are in different forms. The better way is to convert everything into decimal forms. So let's do that. This is now a negative 1. 1.5, half is 0.5, therefore 1.5. 2500 is already decimal, no problem. This one, to change the percent to a decimal, simply move the decimal point 2 places to the left. So 1 and 2, that becomes 0.725, square root of 4, get your calculator, it's going to be a 2. Okay, now we're ready to graph them. Since we already know the decimal values, negative 1 goes over here, 1.5 is positive, so you go over here, right? No problem. But take note, when I label it, I don't label it with a decimal, I label it with the original number. Okay, label with the original number. 0.25 negative is before reaching half, so you're over here. I label it down, and then 0.725 is over here. Put a point, okay, and label with the original. And 2 whole number is over there. So put a point now. It's a range from least to greatest. So convert to a decimal, divide using a calculator. Negative 1.5, 0.625, 5 divided by 4, 1 divided by 4, negative 3 divided by 4. I can now plot the points. You go here, 0.625 goes over there. All right, 1.25 goes here. 0.25 is positive, it goes there. Negative on the other side goes here.